When you use an LLM, do you know what is the underlying architecture you are using in all the transformer architectures? Is it encoder only, is it decoder only, or is it encoder to decoder architecture? Welcome to Unfold Data Science. My name is Aman and I am a data scientist. In this video, I am continuing my LLM for application development playlist, and I am going to cover these three categories of transformer based models: encoder, decoder and encoder-decoder. We will understand what are their purposes, what are their use cases, and we will do a small Python demo to understand how these work. Let's start. Let's go ahead and try to understand what will be the flow of today's video. First of all, we are going to see why different variants are needed in transformer based models. So why we can't have just one variant, encoder decoder variant, why we need multiple variants. Then we are going to understand how these are different. So how these are different in terms of training requirements, how these are different in terms of what is the use case it is trying to solve. Then we are going to understand the specific details of these architectures or models. One important category is encoder only model, and one important very well known model in this category is BERT based model. Another important category, decoder only model. World famous model in this category, ChatGPT or any GPT based model. Third category, encoder decoder model, very famous model, T5 family of models in this category. So we will understand how they are different, how they work differently, how they are trained differently. Then we are going to understand all the concepts through Python so that you are not confused when somebody is trying to confuse you in an interview setup, and also you are confident when you are building applications using these models. So why different variants are needed? The first question. We will take this question, but before that, let me try to tell you what we have been doing so far in this playlist. If you go to YouTube and if you go to LLM for Gen I application development playlist by Unfold Data Science, so basically what you need to do, you need to go to YouTube and you need to go to Unfold Data Science and playlist and click on this LLM for Gen AI application development. You will see that I have started from generative AI, then covered LLM, then covered transformer related concepts, and in the end, transformer explained I covered in the last video. So what I did in the last video, I have covered in detail the transformer architecture, what you see on the screen now. If you have not watched my last video, you must watch that. Reason being, you will be very confident on understanding how the architecture is. Okay. And to know all the details, you must see some of these videos as well so that your concepts are very solid. That was about transformer architecture that you see in front of your screen. So transformer architecture I was explaining in last video as well. It is basically encoder decoder architecture. What you see on the left side is encoder, on the right side is decoder. But here the question we are trying to answer is why we need different variants such as encoder only, decoder only, or encoder decoder model. The first thing we need to understand is the world of natural language processing is very complicated, and in this complicated world there could be different kind of problems that we might be interested in solving. For example, one problem could be, I am just giving an example here. One problem that we may be interested in solving could be, let's say I want to solve a problem of topic modeling, just an example. So there are different topics. I want to understand the context and I want to just categorize it into various topics. This is one example. Another type of NLP use case could be summarizing something. So I give a article and the model need to summarize that article. The third kind of thing could be language translation, or maybe let's take a translation on it only to keep it simple. Translation. In all these three types of problem statements, right, you don't need a complete encoder decoder architecture. So I will explain you here the complete encoder decoder architecture, what it does when I was explaining you transformer in last video, right? This is encoder. It will take a sentence, encoder. It will take some sentence it will give the context to decoder, and what decoder will do? Decoder will generate the, basically if it's a language translation, then input to output. Now imagine you are doing a topic modeling. Imagine you are doing a topic modeling. So imagine that there are 10 articles in front of you. Okay, there are some news articles in front of you, and you can think of 10 news articles. What you have to classify is which of these topics are, let's say, politics, and which of these topics are, let's say, sports. In this kind of scenario, you no need to have a decoder. I will tell you why. You no need to have a decoder because the only thing you are interested in is this context. So you remember I told you encoder sends the context to the decoder. In topic modeling scenario, you no need to have a decoder. At the moment you have a context, you are done. You can do the topic modeling. Hence, in this kind of scenario, we use encoder only model. Let's take another NLP use case for summarization, or let's say chatbot. Okay, any kind of situation where we are trying to generate something in a sequence. So for example, let's say I give a sentence like I love, and I want to complete this sentence. Or I give an article and I want to summarize this article. In this type of scenario, right? In this type of scenario, what I can do is I no need to have an encoder. The reason being, my decoder is also capable of understanding this and generating the next word, because decoder is also has its own layers, right? If you remember, decoder has its own attention, decoder has its own feed forward, everything decoder has, right? So in this type of scenario where I'm summarizing, I'm auto completing, I'm generating something, in this type of scenario, decoder only model is enough. We don't need encoder. So here I will use decoder only model. But imagine a scenario of sentence translation. Here I need to read input sentence, get the context, and then generate output sentence. So read, get context, then generate. What I will go for is encoder decoder architecture. So what you need to keep in mind here is very simple. Based on what problem you are solving, okay? Based on what problem you are solving, you will use only encoder, only decoder, or encoder decoder architecture. Based on what problem you are solving. And you should always remember this, based on problem model is chosen, or architecture is chosen, you can say. What problem you are trying to solve. Now, one important thing you need to understand here is when you are choosing encoder only model trains, when the model training happened, right? Only encoder. This is a very important concept. Remember this. They will try to confuse you in interview. Decoder only model trains only decoder, and encoder decoder model. Encoder decoder is not only, encoder decoder model trains both encoder and decoder. So basically the complete architecture of transformers. So this is a critical concept to understand here at this juncture. Now one important thing here is when I am saying that only encoder is trained, or only decoder is trained, or both encoder and decoder are trained, then one thing will change here. You know what is that? That thing is, what is your training task? So here I will write here model type and training training task. Now pause this video for a moment and try to think, if you are training a encoder only model, then what kind of task you want to have here in training. So what does encoder model do? Encoder model tries to understand the context of your given sentence. So what task you want to train here? What task you want to train here? And same question for decoder only model. I gave you an example of what decoder only model does, right? If you are training a decoder only model, then what kind of task you want to train your model on? And same question for encoder decoder model. Same question for encoder decoder model. What kind of training task you will want your model to train on? If you are not able to think, then let me try to give you one hint. Here, the task normally used is masked language modeling. What is the meaning of that? We will come to that. Mask language modeling. In decoder only modeling. In decoder only, the task that you are trying to train your model in is causal language modeling. Causal language modeling. And in encoder decoders that you have seen in last video as well, the task you are trying to train your model could be any sec to sec model. One example could be language translation. Any models of this type. Fine. So I will just revise once before we go deep into encoder only model. I will just revise what we have discussed till now. The original transformer architecture is encoder decoder architecture, but due to the usability and complexity of various tasks in NLP, based on what task we are doing, we choose either encoder only or decoder only models. And I gave you some example of where encoder only, where decoder only model will be chosen. And encoder only model trains only encoder, decoder only decoder, and encoder decoder both. Example of training task is masked language model in encoder only, in decoder only causal language model, and in encoder decoder sec to sec. Now let's take a step forward and try to understand more details of encoder only model. What is the meaning of encoder only model is only this part will be there, left part, right part won't be there. So input sentence should come and context should get generated. That's it. That is what encoder only model will do. Fine. So what is the purpose of encoder only model? If somebody asks you what is the purpose of encoder only model, what is the purpose? Can you comment me by pausing this video? Understanding input. Understanding input. And when I'm saying understanding input, then what kind of tasks will come here? As I told you, name entity recognition, topic modeling, classification, any kind of tasks. What is the training task that it is trying to solve? Training task. Training task could be input sentence, input sentence with masks, with masks, goes to encoder, and what encoder does? Encoder predicts masked tokens. What is the meaning of this is very simple. If there is a sentence, I am test, cricket. If this is the input sentence, right? Then let's say this word here will be masked. Let's say this word is originally playing, but this word will be masked. And this sentence will be sent to the encoder. And what encoder need to do? Encoder need to predict masked token. So whatever you have masked, right? Encoder need to predict this. This is entire training process. And in this training, right, encoder will learn the context of the sentence. And this process, what is this process? This process is called masked language modeling. Okay. So what is masked language modeling? You take a sentence, you mask some part and you send it to the encoder. Encoder tries to predict the masked thing. That is your masked language modeling. And what will come as output from encoder? From encoder, the enhanced contextual embedding or context of the sentence will come as output. So if I take this sentence and if I give it to encoder, right? I mean, after the model training has happened, then what will happen? I will get four embeddings, right? Embedding of I, the enhanced contextual embedding basically, embedding of M, embedding of plane, and embedding of cricket. So enhanced contextual embedding of this will come, and basically context aware vectors. And we can use this for whatever purpose we want. This is your encoder only model. And this is usable for what kind of use cases? If I have to name some use cases, right? For example, text classification, text classification. There could be name entity recognition, NER. There could be, as I told you, topic modeling, topic modeling. There could be semantic search, right? You want to know which are the similar things. And many places where you think that understanding context of the input is a helping thing. There you can use this encoder only model. What are the some famous model in this category? All the BERT models that you hear about, BERT, Roberta, Albert, right? All those are encoder only models. And sentence BERT, fine tuned, all those are encoder only models. So let's go to Python and try to build a small code that will help you to solidify your concept. So let me write here encoder only model. And what we are going to do is we are going to import some model and work with that. I will show you how the model works actually. So let's go to transformers and import a BERT model basically. So if you see here, I'm saying from transformers, import BERT tokenizer and BERT model. I told you BERT is a what kind of model? Encoder only model. I'm importing that, and in tokenizer, I will import one of BERT tokenizer. So BERT base uncased, okay? We will see how it is processing an input sentence. So here I'm importing the models. Here I'm trying to uh, import the tokenizer. And what I will do now is I will just generate some input from an input sentence. For example, here I'm trying to generate inputs. I'm calling tokenizer method on transformers are powerful. This sentence basically. So my first code has run, grant access. First code has run. The second code, the model is tokenizer is imported, model is imported. Now I'm creating inputs for this sentence. Transformers are powerful. Okay. So I have the inputs, and let me import the model. Let me import the model, the BERT model, BERT base uncased. So tokenizer from the same model also I'm taking the same model. And then I want to see the outputs from this model. That is what I want to show you basically. So I'm giving inputs to the model, and then this is my output. So what will be in the output? Again, I want you to comment me. This is my sentence. Transformers are powerful. What do you think will come in the output here? Go back to our note here. What I was telling you is in encoder only model, you give your input. What you get is a contextual embedding, context aware vectors. And these we can use wherever we want. So In my output, what we will get is context aware vectors. So this output, right, if I have to print and show you, you can see that these will be context aware vectors. So to see that, right, I want to show you shape of that first. So if you see, right, outputs dot last hidden steps, basically shape of that 16768. What is the meaning of this? Who can tell me? So the meaning of this is one sentence, six tokens, each token's dimension is 768. One sentence, my sentence is what? Transformers are powerful. How many tokens? Six tokens. But you will think that I have given four tokens only here. Why six tokens? Because one in the beginning and one in the end, it is acting by itself, BERT model. And 768 is the dimension. So if I have to print that, right, you will see that it is giving me embedding for six tokens. See here. This is the embedding for first one, second one, third one, fourth one, fifth one, and sixth one. So what you are getting? You are getting context aware embedding of your input sentence. Now you take this, you use in any language model, any kind of topic modeling, any kind of name entity recognition, any kind of semantic search, whatever you want to do. That is your encoder only model. Now let me write here decoder only model, and this is very interesting category. Reason being, chat GPT comes into this. So what will be decoder only models? Decoder only models. As we were discussing in the beginning, in decoder only model, what will happen is we just want to use the decoder part, meaning we want to give a sentence here or some tokens here, and usually we want to predict the next token. So that's what we want to do. We want to do some kind of auto completion, we want to do some kind of question answering or these kind of things, right? So the task which we will be solving here is basically causal language modeling. So what is the meaning of causal language modeling is the purpose here is auto completion. First of all, we need to write the purpose first. So purpose is basically um, auto completion or generation, text generation, code generation, right? So for example, generation, auto completion, etc. These are the purposes. For these purposes, the task we are trying to solve here is basically causal language modeling, also known as CLM. What happens in CLM? CLM is a very simple thing to understand. This we have been seeing all this while. The cat sat on the blank. So you will take your input data and you will just want your model to predict the next word. That's it. So for example, this is your entire sentence. You will take the entire sentence, and what model need to do is model need to first look at, for example, model predicted the. So this the will go to the model in next iteration, and model will see, okay, after the what should be there. So model will say the cat. Next time model says, okay, after the cat, what should be the next word? The model says the cat sat. Okay, after this, what should be the next word? This is the job of the model once the model is trained, right? But when the training is happening, how you train the model is basically you tell the model to predict next word in a sentence. That's it. That is called causal language modeling. Fine. And in this causal language modeling, there are multiple kinds of use cases as I was talking. And those kind of use cases could be, for example, chatbot, QA systems, any kind of QA systems, all kinds of tasks that you in ChatGPT and Gemini, right? Any kind of generation, code generation, text generation, email generation, all those things are part of this. For example, creative writing, poetry, all these things are part of this decoder only model or architecture. And the famous model in this category, no need to mention, but again, GPT family of models, everything in chat GPT, whatever you hear about, GPT, all those big famous LLMs, Llama, Mistral, CodeGen, whatever is generating, right, that will fall in this category. So these are your decoder only model. Remember this. And how the model learns by causal language modeling. What model learns to predict the next token given the previous tokens. In the generation process, it will generate token. Then this token also goes as input. Then next, then these two goes as input. Then next, and so on and so forth. And if you have to do something in Python using decoder only model, let's try to do that. So for decoder only model, right? What we need to do, we need to first import. So as I was telling you, GPT-2 tokenizer and GPT-2 LM head model is what I'm importing because GPT is what I want to play around with. This is tokenizer. Fine. Then this is my model GPT-2. Fine. And what I want to do is I want to generate something. So I need to give a sentence here. That is what I will do now. I will say tokenizer once upon a time, comma, this sentence I'm giving. And I'm saying input IDs because these IDs I need to pass to the model, right? And then I will pass to the model these IDs. So I will get some outputs and then these outputs I can see. So if you want to see the output, right? So it will generate basically some tokens and then we can decode and see those tokens. Once upon a time, it was always a bit of stretch to think about just when this something, okay, something it is generating. So what does decoder only model do? It generates things for you. Fine. If you're liking this kind of content, guys, I'm trying to bring in some theory plus some labs plus practical everything so that I give the best to you. Please don't forget to drop me a comment and like. That motivates me. Okay. Now let's go to the next type of model known as encoder-decoder model. And this is an easy one to understand. Reason being, you have already understood if you are with me in this playlist, right? You have already understood the transformer architecture, and that is nothing but encoder decoder original transformer, right? Sec to sec architecture. So something will come, go in encoder, context will be generated, go to decoder, and then something else will come, which is maybe a language translation or any sec to sec task, right? So but still, let's see some details of these models, right? What is the purpose? Translation or summarization or anything that maps input to the output. So I will write here encoder decoder model. Fine. What is the purpose? What is the purpose of these kind of models? Translation. Some purposes I'm writing. Translation. Maybe Q&A here also. Maybe anything that maps sequence to sequence. Anything that maps input to output. That will be your encoder decoder kind of architecture. And the training process that it tries to follow is basically sec to sec learning. Sec to sec learning is simple to understand, which we discussed in last video in detail on transformer, right? And what will be the kind of input and output sentence? For example, input could be how are you, and output could be आप कैसे हैं. So this could be my training data that can go inside the model, and my model can learn from this how to translate English to Hindi. Fine. So this is how it can happen. Kind of use cases that it can use is translation. Translation. Kind of use cases it can use is, for example, summarization. Summarization. It could be Q&A. Q&A. And it could be rewriting. Rewriting. Anywhere where you can think of generating some output from a given input, you can think of encoder-decoder kind of architecture. The famous models in this category is basically T5, BART, Flan T5, and many other models in this category you can search for. Let's get the feel of how these models work. So what I'm going to do is I'm going to do a similar exercise here in Python for this as well. So let's import some models. T5 tokenizer and T5 for conditional generation I'm importing. Let me generate the model. Let me import the model. Let me import the tokenizer as well. And let me call the model with the input sentence. But before that, I need an input sentence. So this is my input sentence. In today's fast changing world, students must adapt to a mindset of continuous learning. New technology, shifting industries, and global economic changes mean that knowledge can become outdated. So something about knowledge. And then what I will do, I will bring in the tokens and I will just generate using this model. Fine. Once this is done, what I can do is I can see my output. So I'm saying summarize. So it is summarizing. Okay. So as I was telling you, summarize is one of the tasks of these kind of models. So three kinds of model. Simple to understand. You understood what are the tasks, what are the things it can do, what are the activities we can perform, what are the use cases we can use for. Now, one question that might be coming to your mind is that all? Is it only encoder, decoder and encoder, decoder? So I asked this to ChatGPT and I got a very nice picture from ChatGPT, which I want to share with you. So here, if you can see, right, this is ChatGPT gave to me. It is telling me type of transformer model encoder only, decoder only, encoder decoder. So these are mostly the types, but you should also be aware of RAG related, I mean RAG based models, some memory efficient models. So these are small changes in the transformer architecture basically. Multi-model, instruction tuned model, and mixture of expert model. So I'm not saying these are new things. I'm saying these are little variation on top of what original architecture we have. Fine. So my I need action from all of you. I want you to tell me which of these models you use more. Do you use encoder only model? Because in my upcoming lectures, I will show you that all these models has its own usability. But I want to know from you, are you using encoder model only? Because what I'm assuming is you are using decoder only model more. But I want to show you the power of these models and these models as well. Hence, please write me in comment which models you have used in your work till now. And then we will go from there. That is one thing you need to write. And second thing you need to write is whenever you are building any model, right? How are you evaluating that? There must be evaluation, right? How are you evaluating that? How model is good or not good or whatever. Fine. And last but not the least, guys, I totally depend on your likes and comments because I see less likes and comments nowadays, and that's little demotivating for me. If you can just drop a comment, that will be good for me. So see you all in the next video, guys. Wherever you are, stay safe and take care.